Hi everyone, this is Sumit K. In this video, we are going to see how we can use Terraform to set up our cross-regional internal application load balancer. If you don't know what is cross-regional internal application load balancer, then I have already uploaded a video in my YouTube channel where I have covered everything uh, about this service from the scratch. I have also compared this service with the regional internal application load balancer and why this cross regional internal application load balancer is currently is in the preview mode, so you won't be have access to create it from the GUI console. Once it is live or it is in production, then you can use it from the GUI console. So most of the option you will use either a GLI command or a Terraform code. So everything has been covered on my previous videos, so you can just watch it. And so here in today's video, we are actually going to deploy this cross-region internal application load balancer using the Terraform. So just to give you a quick walkthrough, what is cross-regional internal application load balancer? So if you know regional internal application load balancer, where where it works as a regional mode. So regional internal load balancer is basically ensure that all the clients and the backends are from the specific region, so which helps you when you need a some sort of compliance, right? But in cross-regional internal application load balancer, it is a multi-regional load balancer, and that is implemented as a managed service based on the open source Envoy proxy. And cross-region mode enables you to load balance traffic to the backend service that are globally distributed. So here you will get a backend service which is a global, but you don't get a global backend service in a regional internal application load balancer. That is why Google has has launched this service as a cross-regional internal application load balancer. So, right. So here the load balancer is also enables a high availability, which is actually placing your backends in a multiple regions, which helps you to avoid the failure in a single region. So let's say, for an instance, if your backend goes down in one region, then your client, your internal client is continue to use the your web server from the another region. So there is a high availability, right? So so high availability and cross region failover, the high availability is the main purpose of of deploying this cross regional ILB, right? So basically, um, uh, here you get a high availability, right? But in normal ILB, in regional internal ILB, you won't get this, right? And that is why we use the cross regional ILB. So let's deploy this in our demo today. So just look at this architecture. What we are going to deploy. So basically, we will use two region: US West one and US East one. In US West one, we will basically deploy some of our backends, basically the managed instance group. And in US East also, we deploy some backends as a managed instance group. And then and both the backends will be attached to your global backend service, right? And then we will also deploy all this network, the subnets, right? And our internal load balancer, which will have two forwarding rules. Here you can see that two forwarding rules, one in US West and another is in US East, right? And the client VM in both the region to test the connectivity. If a user is coming from US West one, the request is going to be served from the backends from the US West region. And if a user is coming from the US East region, then the request is going to be served from the backends from the backends in the East region, right? So this is how you can get the users proximity request to be served from their regional backends, right? So even if in case, let's say, your east let's say your west region goes down for any reason, right? So your client we will continue to use a backend from the US East region, right? So let's see this in demo, how we can achieve this with the Terraform code. So I have a Terraform code with me, so you can see that here. So this is the code. So what we are going to deploy, this is very simple code. Let me just close everything. So so here we are starting with creation of the VPC. We are going to create a VPC with the name my VPC, and the subnet, two subnet, one subnet in the first subnet in US West one region, and the second subnet is East region. Sorry, it's East region. Oh, no, sorry, this is something else. So okay, so we are going to create a subnet in the US West region, and we are also going to create a proxy subnet in the US West region. If you don't know what is proxy subnet, so proxy subnet is used for the cross-region internal application load balancer, basically to terminate the traffic at the proxy subnet, and the new session will be initiated from the proxy subnet. And similarly, in the east region, we are going to create a subnet in the east region and the proxy subnet in the east region as well, right? So here, the IP range for subnet in US West is going to be 10.1.2, and the proxy is 10.129. East is 10.1.3, and the proxy is 10.130 series. You can put any CIDR range here as per your choice. So firewall rule, we are going to create a 3 firewall rule. The first firewall rule is basically a health check for your backends, right? For your load balancer actually, and this is the source range, right? 130, 35, and 35 to 35 are basically these public IP range are owned by the Google itself. And then we are going to open some of the firewall rule on port 2022 80 443 8080, so that anyone from the internet can access this for the demo purpose, right? And this is the this is the firewall rule for your backends. Basically, you are opening a firewall rule from your proxy subnet, right? This is your proxy subnet range, right? If you see here, this is your proxy subnet range, and we are saying from this proxy subnet also you create incoming traffic on this port 80 443 and 8080. So you can see that this is an ingress rule applicable to an instance being load balanced that allow TCP traffic on port 8443 and 8080 from the internal application load balancer managed proxy, right? Because this is a managed proxy range. Okay, now we are going to create a managed instance group in US West 1. So this is a template. I have used a simple template. The name of the template, the machine type, the region, the tags I have going to give HTTP server, and then the network interface. And the in the startup script, I'm going to deploy I'm going to deploy a web server for testing. So this web server, I have a startup script which is in web1.sh. This is the startup script which will deploy at the time of bootstrapping, right? So I just given the path file web1.sh, and this is in my local directory, same directory, right? And again, you are going to follow the manage instance group in the US East, just the same steps, right? Only the reason is different, the same startup script, right? And then we are going to create a managed instance group. Now your template is ready. We are going to create a managed instance group. So managed instance group for US West 1, where I'm getting my template, right? So whatever template I have defined here, I'm going to refer in my managed instance group. And here the target size here is 2. I'm going to just make it 1, and I'll just leave it 2. I mean, I think 2 is fine. And again, here also in the US East, I'm also going to create a managed instance group, make B, in the US East region, and I'm going to referring my template. The target size is going to be 2, which means my auto scaling will deploy 2 instance. And now here I'm going to configure a load balancer. So when you're configuring a load balancer in a cross-region internal application load balancer, these some of the especially the backend service and the front end are not available in the GUI. So you will use a Terraform code or the GLI command, the CLI command. Sorry. So here the first thing you need to create the health check, right? And then I have just named it Google HTTP health check, and then you will create a backend service. So the backend service name is GLB backend service, and this is going to be internal managed. And the backend service I'm going to refer from my US West 1 and US East, right? So both the backends. So these both the backends are going to attach to my common backend service, global backend service. So this is my global backend service. The URL map, right? And then the target proxy, which is again a global target proxy. And then I'm going to refer my URL map in my target proxy. Okay, and here I'm now going to deploy my global forwarding rules. As I shown you here, these 2 forwarding rules I'm going to deploy here, and here you will this you can set in a specific range 10.1.2.9, which you have taken from your subnet, and the network and the target and everything. You can just look at it. And similarly, the forwarding rule B, which is for your subnet 2, I mean in the US East region. And here I have set the IP 10.1.3.9. So basically this IP 10.1.2.99 and 1.3.99 will be placed here, 10.1.2.99 and 10.1.3.99. So I have already reserved it. All right, so this is what the code is. Very straightforward code. I am going to put this code repo in my video description, so you can find out from there. You can also get this code from the Google official documentation. I'm gonna put this link as well. So let's just initiate, sorry, Terraform, Terraform validate. One more thing that you need to ensure that you have a provider um, to be set. So provider is Google project and your credential, right? So you can create a service account and you can create and download the keys and put it here. Like I have put it in my file, the JSON file, and I set the credential path to this file. Okay, so make sure you have this. So everything is looking great. So let me just plan. So you're saying that 18 is to add, 0 to change. So you can see here, like you are going to create 18 resource, right? So you can just review this. So just saying backend service, deploying this backend service, the firewall rules, 3 firewall rules, and the forwarding rules. You can see that, and the health check, right? Compute instance template and compute instance template B, and then you have a compute network VPC, and this is a managed instance group A, managed instance group B, and this is a proxy subnet A, proxy subnet B, and this is a subnetwork. This is also a subnetwork, and this is your target and the URL map, right? So everything looks good. Now we are going to just apply it. Everything looks good. Say yes. And here you can see that the Terraform has been started applying the code, and you can see those resources are being created. Let's just wait for a couple of minutes. So in the meantime, if you just refresh it here, so you can see that my VPC name, the name of my VPC, you can see it from here. See, this is my VPC, and here you get to 2 subnets soon. So you can see that this is your subnets, which is in US East and US West, 2 subnets and 2 proxy subnets as well. So proxy subnets are basically a regional. So once you create a proxy subnet, you can use the proxy subnets per region. Let's wait for some time. If you go to compute engine, so you can see that. So I set 2 VMs, right, in the auto scaling. That's why it is creating 2 VMs in each region. US West 1B, US West 1A, 1D, and 1C. Now it's creating a target proxy. It's creating a forwarding rule. If you go to a load balancer, here you will see a load balancer, internal cross-regional internal application load balancer. So you can see that a load balancer. This is internal. Protocol is HTTP, and here is one backend global backend service with 2 instance group. and this is the ILB name. So you can, I think it has deployed everything. So see, the apply has been complete. 18 resource has been added. So now let's just verify, right? So your VPC is there, your subnets are there, your proxy subnets are there. And if you want to see your firewall is also there. We have created a three firewall rules, right? So all three firewall rules are in place. You can see that all those firewall rules. And now if you go to the VM instance is also ready. Let me show you the template, right? So we have created two template, right? This template is basically a global template, one for our US East region and one for US West region. And we have also created a instance group. So instance group, right? One for US West one, US East one, and having two instance, right, as of now. So here is your load balancer. And what I said that this internal load balancer, this one single internal load balancer got a two front end. So basically this front end is for US West one subnet, and this front end is used for US East one subnet. And then we have a global backend service where we have created two backends. One is from US West one, and another is from US East, and each backend has got two healthy instance, right? So if you see this architecture here, we have created all the resource, right? We have created the backend here and here also, the global backend service, the URL map, the target proxy, and two subnets, and then this VPC network along with this proxy subnet as well. So as of now, um, we have deployed our expected resource, right? So now we it's time to verify the connectivity, right? So here you can see your client VM, and this client VM has not been covered in your Terraform code. So we will deploy this client VM using the GUI console or the CLI command in each region so that we can verify for connectivity and see that if the client VM is can able to access your web server, right? We will do some failover as well. So before we do that, let's first see if my web server is accessible over the internet or not. So how you can test it? Just go to the VM instance, and here let's take a public IP of your instance and put it here. So here you can see that this VM is publicly accessible over the internet, and this is the host name and this is the region, right? So this is how you will see the page when you try to hit your internal load balancer front end from your client VM. Because your internal this is the internal load balancer and cannot be accessed from the public internet. That is why we are using the this client VM, right, to verify the connectivity. So let's deploy it. Let me just deploy it using the command line. So I'm going to create, just a second, let me just I'm going to create my first client VM machine in US West. And also deploy a client machine in US East as well. If we go to VM instance and just refresh it, you can see this is your client machine, right, in both the regions. So let's just SSH into one of let's just SSH into the client machine first in US West. Okay, so to log into this machine, you can use this SSH command from the shell, from your shell as well. So right now I'm SSH into this machine, the first one, this first one. Okay, and now I'm into this client machine. I'm going to curl. What was the IP? The front end IP of US West 1 region 10.1.2.9. So 10.1.2.99. Is it 2.1.2.99? Yes. See, here you can you are getting some page served from the your web server, right? So you can see that the page is served from this host name VM6PQ, and the region is US West 1. So this is important, right? Because your request is coming from a client machine which is in US West 1 region, and your request is serving from the US West 1 region backend, right? Similarly, if you try to log into, let me just log out from this machine, and now I'm SSH into my East machine. And here also I'm going to curl 10.1.3.99, which is a front end of my US East 1. So here you can see that the request is serving from the US East 1, right? So let's just exit out and log into my first client machine, which is in US West 1A. Okay, so this is the way that right. This is the way that you can send the traffic from the client machine. Now, what we am going to do, I'm going to create a domain name, internal DNS, and then we will do some failover, right? So let's first create a domain, because in a real time, in a production, you won't give an individual IP to your client, right? You basically give a single domain name, right? Now, client or your end users are going to consume the single domain name, maybe app.example.com, something like that. And whoever user is coming from any region will hit to this DNS name, and then the DNS name based on this policy forward the traffic to the corresponding forwarding rule. If a user is coming from, let's say, the user is coming from US East, and then it will hit let's say the DNS name, and the DNS name will see from where this user is coming from which region, and based on the region, a proximity to the user's location, it will forward the request to the corresponding forwarding rule, which is nearest to the user, right? So the request will be served from the backends from that region. So let's see this in demo. Okay, so go to DNS. So this is an example.com. This is an internal domain. If you see, this is a private. And if you just click on this, you will see this is in, I mean, if you just edit it, you'll see that, okay, 1 second. I think I have already created a record over here. So let me just delete it first. Let me just delete this record, otherwise you won't understand. Okay, now this is my internal domain, right? The first of all, I'm going to create some routing policy here, right? So I'm going to create a routing policy, and here I'm going to see my app. So this is going to my DNS name, okay? And here the routing policy type is you can set it with 3 types. So I'm setting it with the geolocation, and here geofencing. You just need to set the geolocation policy routing data. So you need to select the region. Let's say you have 2 regions. The first one is US West. Let's go with the US East first. US East, and here your project and the load balancer type is going to be cross regional, and the forwarding rule is going to be 10.1.2.9, which is for US West 1, right? So I'm going to select, right. Similarly, you can add another routing data for US West. Sorry, I think I made some mistake. This is 10.1.2. It's going to be 3.99. So you need to select 3.99 here, because it's for US East. And for US West, this is US West 1 and cross regional. The forwarding rule is 10.1.2.99. Done. Next. So you can see that you can review it. So this is the domain name that the user is going to hit this URL, and the routing policy is going to be based on geolocation. And if the user is coming from USCs, the next forwarding rule is going to be this. And if the user is coming from US West 1, the next forwarding rule is going to be this, right? So please bear in mind. Create it. Okay, so your everything is now this zone is, I think you need to apply to your network as well. So this is my network, my VPC. Just save it. All right, so done, right? So my DNS record now is in place. So right now I'm logging into my client machine in US West 1. So now if I trying to curl instead of IP, I'm going to just simply curl the DNS name, right? My app.example.com. And if you see, your request is going to be served from where? US West 1, because this user is in US West one. Similarly, if you just log into US East one machine, your request will be served from the US East one. So now let's just test the failover. Now what I'm going to do, I'm going to actually um, remove this backend, this sorry remove this backend, the US West one, because what happened right now, you can see that the user is serving from the US West one backends. Now we are going to verify the actual purpose of cross region, how the failover implements. So we are actually going to remove this backend, and now when you hit this request from this client machine, your request from the DNS will forward to this forwarding rule, and this forwarding rule in the US East region will forward the request to the backend instance in the US East one. So let's see this, how we can do that. Okay, this is my west, so I'm going to remove this. Simply just select it and let's just delete it, or simply just remove it, not just delete it, just remove it. So basically I'm removing this this backend, this manage instance from the backends, right? I'm removing this instance from the manage instance group, right? So ultimately my VM is down. You can simulate that. So now if you go to your instance, now let's see what happened. If we try to curl, yeah, can you see that? This now this time, when you curl myapp.example.com, the request is serving from US East one, right? It is so fast, right? The request is serving from the US East one. Earlier, if you see above, earlier it was serving from the US West one, right? So similarly, if you log into US East one, and if this backend goes down, then the client VM can continue to serve from the US West one region, right? So this is how you can verify that the client can reach to any region using the cross-regional internal application load balancer. So that's it for now. I hope you have enjoyed this session.